get into teaching on this one. So the main thing, if you guys remember in the vectors quiz, I kind of got upset with a couple people because they got confused and they didn't even bother trying to graph it. And I don't even know what negative square root of 3 is. But I bet it's somewhere between 1 and 2, because 2 squared is 4, right? So the square root of 4 is 2. So it has to be large, it has to be smaller than 2. And the square root of 1 is 1. So it has to be between 1 and 2. Would everybody agree with me at least on that? So 1, 2. So it's somewhere in between there, and then up 1. So I don't know where this point is, but I know it's somewhere in there. And again, we're trying to write this in rectangular form, meaning we're trying to find this length r and this angle theta. So again, create a triangle. We know this horizontal distance is negative square root of 3, and we know the vertical distance is 1. So we have enough information to find r, and do we have enough information to find theta? Bless you. Yes, there's no magic formula you guys need to memorize. It's the same stuff we've been doing over and over. So to find r squared equals x squared plus y squared. R squared equals negative square root of 3 squared plus 1 squared. So that becomes 3 plus 1 is 4. Root. R equals plus or minus 2. But since we're talking about distance, we're only going to deal with the positive 2. However, if you remember what we talked about, that positive or negative, you can do the inverse, directional sign. So the negative can work. You just need to make sure you change your angle. So there r equals 2 in this case. And then we need to figure out the angle. So you do tangent of theta equals opposite over adjacent. So 1 over negative square root of 3. Therefore, theta equals tangent inverse of 1 over negative square root of 3. So when you go ahead and use a calculator, somebody stole my calculator. Here's my calculator. Negative 60 degrees. Now that is interesting.
Because I don't have a note on my calculator, but it's just negative.
Well, there's a problem. Does this angle look like negative 60 degrees? Are you sure it's negative 60 degrees? Negative 1.81.
That's what it's saying.
Can I see your calculator? Can I use yours? I just want to type it in. You got 30 degrees. No, that's right. I think 30 degrees is right. I don't know how you got 60 degrees. 30 degrees sounds right to me. It's going farther horizontally than it is vertical.
Oh, you know I did. And I did negative square root of 3 over 1.
That'd be it. That'd be exactly it. So 30 degrees. Either way. Guys, does this look like negative 30 degrees? In standard form, does this look like negative 30 degrees? No. That's not 30 degrees in negative. From what I'm trying to say is, from here to here, that's your angle, right? In standard form, that is not negative 30 degrees, right? So we got to think, why is our calculator giving us negative 30 degrees? Your calculator is right. But if you remember, inverse tangent is only within the first and the fourth quadrant. Remember those constraints that we talked about. So what your calculator is giving you is that angle right there, which is negative 30 degrees. So what you need to understand is, if that's negative 30 degrees, that means that is positive 30 degrees. But we need to figure out this angle. So if here's 30 degrees, halfway around a circle is 180. That means this angle is 150 degrees. Or if I asked you to do this all in radians, you could have quickly converted pi over or 30 degrees to pi over 6, right? And then for this would be 5 pi over 6. But anyways, let's just do it in degrees. Actually, yeah, it's 5 pi over 6. Or 2 equals 150 degrees. So just be careful with that.
So is theta always from standard?